Okay, the last time we started talking about alcohols, we saw the general formula, which is CnH2n plus 1 OH. We saw a couple of, well, a few methanol, ethanol, propanol, and butanol. And we also went over isomers, right?
Yeah.
So, isomers, how to identify, how to name them, right? We looked at something a bit more complex, right? Hopefully, you guys still remember how to do that. Okay. And so today we are going to continue and talk about some reactions that alcohols undergo and then the manufacturing of alcohol, right? The different ways of doing that. And if time permits, we'll move on to talking about carboxylic acids. Now, some things they say about alcohol, some of their properties and uses. Uh, the book mentions that alcohols relative to their molecular weight, so their well, not weight, like molecular mass and their size, they have high boiling points. They have high boiling points and relatively low volatility. Right, volatility is when you got a liquid. Have you guys ever used nail polish remover? Hmm? Or thinner,
Yes.
right? And so, or petrol for that matter, right? If you've been near it, and so you can, like, if the bottle's open, you can smell the fumes. Why does that happen? Right, is because they're so volatile. Like, even at room temperature you're not providing any energy or anything, and as soon as like they're exposed to the air, right, vapors start coming off, so you could say like that technically they're evaporating, right? So when that happens, it's saying that it's very volatile, or not very, but it's volatile, meaning that it just quickly, right, changes from liquid to gas. And so to contain it as a liquid, you need to put a lid on it, right, to stop the vapors from escaping. And so when they're not escaping, right, the lid becomes, like, there are vapors inside, but then they fill up the available space, and so the rest of the liquid remains as liquid, right? So they've got relatively low volatility given their molecular mass and the size of the molecule. Now, when they're saying they have high boiling points, we are looking at stuff like, methanol is 64 degrees centigrade and butanol is 117, and you're like, that's not high. Well, again, it's relative, right? Compared to perhaps other molecules of this mass, right? Their boiling points are higher for the alcohols. Also, they're polar molecules. Have we talked about polar, like the polarity of water? I do recall we've talked about it. Have we? So, I mean, is that is your silence a yes or a no? I take it as a no.
I don't know.
I take that as a no. So, right, water is a polar molecule. What that means, right, it's a covalent molecule. We know that. But the thing is, right, the electrons are being shared, right? Covalent bonding is electron sharing. Because oxygen has more protons in it, right, and right, hydrogen only has a single proton, oxygen has six of them. And so what happens is that oxygen is pulling the shared electrons more towards itself. So if I redraw that, right? The electrons are being shared, but they're sort of pulled towards oxygen. They're closer to oxygen in a way, right? And what that does is it causes oxygen to have a slight negative charge, and right, because the electrons are closer, it's not a proper negative charge, it's not an ionic compound, right, which is because of loss or gain of electrons, but it's just that it sort of has more of a share of the negativity of the electrons as compared to the hydrogens. Because of that, because hydrogens have lesser of the electrons to share, and so they develop a, what I'm writing over here is the Greek symbol delta, right? So this is lowercase delta, and this is something you're familiar with, right? The triangle, that's the uppercase delta, right, in the Greek alphabet. So
Okay.
in this case, right, it sort of looks like an S with a very curvy, like lower part, right? And so it's like a slight negative and a slight positive charge. And so what this does is it actually helps water dissolve many substances, especially ionic compounds, right? So when you put salt into water, it separates, right? As sodium ions and chloride ions. And why does that happen? It happens because the water molecules sort of surround it. Because sodium is right positively charged, it gets surrounded by water molecules with the oxygen facing towards the sodium because it is slightly negatively charged, and so it's able to pull the ionic compound apart and surround the positively charged sodium ion. For chlorine, it's the opposite, right? And so it gets pulled apart and it's surrounded by the hydrogens, sorry, this way. So it's surrounded by the hydrogens of water because they have a slight positive charge, and so obviously positive and negative attract, right? So similar to water, alcohols are polar because, right, you got CH3OH, and so the O, right, this part is neutral in terms of charge, right? It's got nothing, but the OH part, right, same thing. Oxygen has more protons, right? This is covalent, and so it's pulling the electrons that are shared between the oxygen and hydrogen. It's developing a slight negative charge, and the hydrogen is developing a slight positive charge, right? And so this part of the molecule is polar, and so the entire molecule is polar because of it. And what that polarity helps to do is it makes alcohols and water miscible, right? What miscible means is basically they can mix with each other, mix together. Okay. And so
Yes.
a property of substances like these are that they are organic solvents. So they can, like, an alcohol can mix with water, and it can, because right, in this case it's a short chain, but if you got something like butanol or propanol or pentanol, something like that, it can not only interact with water, it can also dissolve, for example, an organic compound such as, right, propane, which doesn't have any like charge on it, right? So we know that it's not going to mix with water, because to mix with water you need some sort of charge or something. So that's not happening, but it will mix with the alcohol because it's organic as well, right? And so these guys are organic solvents. Does that make sense?
Yeah.
Okay. You've got stuff such as food flavoring and as I mentioned, solvents and glues and a lot of other products and perfumes, and all of these use alcohols. And obviously there's a certain uh, alcohol that is also consumed uh, by humans, right? So all of that. Now let's get to some of the reactions. So the first thing we're talking about is combustion. Remember combustion?
Yeah.
So ethanol, for example, it can be used as fuel, and I believe it was mentioned earlier, right? That ethanol is like an alternative fuel. It's a biofuel. It will burn much cleaner than petrol and everything, but then there's the disadvantage of, having large areas of land to cultivate the crop, which will then be used to, make the ethanol and all of that. So what does this give us? It gives us, right, it burns in oxygen to give us carbon dioxide and water. So the example is ethanol plus oxygen, right, gives you carbon dioxide plus water, and it releases energy. So it's exothermic. And the equation for that would be, right, it's ethanol. So could you give me the structural formula for ethanol?
For ethanol, right?
Yeah.
It is C2
Hmm.
H6.
C2H.
Yeah, H6.
No, it's not H6.
5.
Yeah.
And then
Right.
OH.
Yeah. Now that is the molecular formula. So we can go with that as well. But what I actually asked you was the structural formula. For that, you would have told me CH3,
Oh, CH3.
CH2OH.
Yes. Okay, yeah.
And then to balance this, you've got three oxygens. This guy is a liquid, this guy is a gas. And then you're going to get two carbon dioxides, which are obviously a gas, and three molecules of water. And this is also a gas in this case. And you are, right, getting energy out of it. Okay. So methanol is used as a fuel, right, in domestic burners in parts of the world, and it is poisonous, right?
Okay.
So methylated spirits, right, the stuff that they use in hospitals to disinfect surfaces, and the cotton swab that they use before, pricking you with a needle,
Yeah.
that is wet. It has it has methylated spirit on it, and so that's methanol with other stuff mixed in to kill bacteria and other microorganisms and stuff, and to avoid infection. So people like, right, uh, tend to drink that thinking that it's just alcohol. So it's like the kind of alcohol that they consume, and it's not, obviously. Again, I'm talking about methanol, right? What we did over here is ethanol. So methanol is used that way in countries. Okay. Ethanol is in like in some countries it's mixed with petrol to make it more clean, right? So it doesn't produce as much pollution as just petrol would. This detail is obviously given in the text. Any questions about this part, the combustion part?
No.
Okay. The other thing we have is oxidation, right? So oxidation, remember, reduction, oxidation, right? It's about oxidation is about the loss of electrons, or uh, the uh, loss of hydrogen, right? And what else? Right, it is the gaining of oxygen, right? Remember?
Yeah.
So we're going to talk about how an alcohol can be, right, oxidized. And so what happens is you have ethanol and you have oxygen, and you provide heat, and what you're going to get is ethanoic acid and water. Now the question is, how is this reaction different from this reaction? It's the same thing, isn't it? It's ethanol and oxygen. So why are we getting different products? Why is this oxidation and not combustion? Right? And the reason being is because you are using, right, the oxygen is coming from an oxidizing agent. So you're not using direct oxygen, right? You're using an oxidizing agent. So oxygen is from oxidizing agent. And in this case, the guy that we are using is acidified potassium magnate 7. Let me write that down. Acidified potassium manganate 7. Right? So it's an oxidizing agent that's providing the oxygen. It's not directly reacting with the oxygen in the air, and so it's not combustion. Okay? And so what's happening, if you draw this out, you have ethanol. So you got this guy. And it is reacting with, right, 2 atoms of oxygen. And then what you're getting is a ethanoic acid. So it still has 2 carbons. No, sorry. Right? And this is what it looks like now. And this part is called the carboxylic acid group or carboxyl group. And so this is ethanoic acid. And obviously you're getting water. So writing that out in molecular formulas, you got C2H5OH plus 2O, and that's giving you, right, CH3. So this is how we write it out in case of carboxylic acids. You're getting CH3 COOH plus H2O. And so, right, for example, if we were doing, right, butanol, so that's C4H9OH, and then you've got oxygen, right, and still going to be 2 over here, and so you're going to get, right, you remove one of the carbons, so that's C3, and then you've got H how many, right? 7 and COOH plus H2. Okay. So the question
Yes.
is, where did 2 of the hydrogens go? Right here. Right? How many oxygens are there? This guy already had an OH, right? You're putting in 2 oxygens. You've got 2 oxygens here, 1 here. So it's all balanced. I'm just showing you, right, how you'd write it out. So if they give you an example of butanol, like, oh, we didn't do butanol in class. This is how you do it. Right?
Yep.
So you've got 4 carbons. So this is butanoic acid, right, from butanol. And so you write 1 carbon as COOH. Out of 4, how many are left? Right? You've got 3 left over here. And so how many hydrogens? So 2n plus 1. So 3 times 2 is 6 plus 1, 7. Right? And you're like, well, we started off with 9 hydrogens. Yeah, they're over here with the H2O. Okay?
Yeah, got it.
Haram, you clear on this?
Yes.
Okay. And so that is the oxidation of alcohols to carboxylic acids. Next up, manufacture of ethanol. So one method of manufacturing ethanol is biotechnology, right? And biotechnology is the use of either microorganisms, biotechnology. So that would be the use of microorganisms or something that they make. Microorganisms or their products, such as, maybe an enzyme, some chemical that they make, such as an enzyme. Remember, we've come across enzymes when we were talking about catalysts. To the benefit of humans. Right, so an example of that is bread, right? Making bread or making yogurt. Different microorganisms are used. In bread, you're using yeast, and that causes the bread to rise. In yogurt, you are using, right? So yeast is actually a fungus. We're not going into biology, but just telling you. And you're using 2 different types of bacteria over here, Streptococcus and Lactobacillus. And what they do is that they, convert the milk protein, they solidify the protein in liquid milk, and that's what gives you the yogurt. So it causes the milk to curdle, if I remember the term correctly. Right, so these are just examples of biotechnology because you're using microorganisms to achieve this. And so another thing that right, so what we're going to talk about over here is yeast. And what yeast can do is it can utilize sugar and convert that into ethanol, right? But it can do that when conditions are anaerobic. What does anaerobic means? Right, meaning that there is either very low or no oxygen, right? So we need oxygen because we're living creatures. Most other organisms that are alive need oxygen to survive. There are certain organisms that don't require it, and there are other organisms that that can switch, right? So if there's oxygen, uh, they use that. If there's no oxygen, then they've got other ways of surviving. Yeast is one of them. And so what we make use of is its ability to convert sugar into, like, if there's oxygen present, it will not convert it to ethanol. We want ethanol, so we're going to put it in low oxygen or no oxygen conditions, and it's going to utilize the sugar and make ethanol for us. And this process is called fermentation. Even though you're not doing it industrially, like sometimes at home when you've got fruits, for example, and they sort of spoil if you've kept them out, or even the fridge, and sometimes you smell them and you've got this sort of strange odor, this sickly sweet sort of smell coming from it. And if you ever tasted it, sort of like a bit of sour and stuff like that. Have you ever, experienced that?
Yes.
Yes. And so that's basically the right fermentation happening on that particular fruit or vegetable that you're dealing with, right? Not necessarily with yeast, like, but whatever microorganisms on it, that's what's happening, right? And so that's an indication that the food is in the process of being spoiled. Okay, so the equation for fermentation is you got glucose and, right, you're using yeast and no oxygen, or you can write anaerobic, and you're getting ethanol, right? Glucose is a sugar, and carbon dioxide, right? This is the equation. The process can be carried out at, room temperatures, so 25 to 35 degrees centigrade works best, right? Maybe slightly higher to speed it up. And right, I mean, you could go up till perhaps closer to 40, but preferably not that high. And yeah, you don't need anything else. So the molecular formula equation, right? Glucose is C6H12O6, and you need to remember that. And you're getting ethanol, which is C2H5OH plus CO2, right? And you're getting more ethanol, right? You're getting 2 molecules ethanol for every molecule of glucose, right? And you're putting that in what, like, it's aqueous over here. This guy is a liquid, and this guy is a gas. So if you ever, like, you can look up a video, and so you'd see the bubbling and the gas being produced and everything. In fact, uh, yeah.
Okay.
Any questions about that?
No.
Okay, so industrially, the fermentation of glucose with yeast is, right, carried out as a batch process. And what that means is, right, uh, the whole batch moves through one step of the process before, or goes through one step of the process. I'm going to use the word move later on. go through one sort of the process before moving on to the next. Right? This is in contrast to what is called a continuous process, right? Where you've got perhaps 5 different stages, and so some of it is on stage one, some at two, some at three, and some at the last stage, and you're constantly feeding in material and you're constantly taking out material, and you've got materials at all these different stages. That's not what's happening in the batch process. Okay, so in the batch process, what you're doing is you're taking this entire batch that you set up, and the whole thing goes to step 2 and then step 3, and then the whole thing is removed, right, with the product and everything, and then you start a new batch. Okay, all right, yes, no,
Yes.
okay.
Sir, I had a question.
Yeah.
Like in the earlier equation, did like every compound had enzymes in it?
Hmm. This
Like
one,
did every compound? Yeah.
every compound have
Have you seen?
enzymes, meaning,
Like I don't know. Like only yeast had or other as well?
I mean, are you trying to ask whether enzymes are involved in this reaction?
Yeah.
Yes, right, but we're not
Okay.
talking about that because we are taking the whole microorganism, and so we're talking like the yeast converts it to ethanol. How does it convert it? Right, the process is catalyzed by enzyme, so it is an enzyme catalyzed process, right? But because it's biological, we're not going to that detail, right? When you study anaerobic respiration, I believe we've covered anaerobic respiration. No, we haven't. Have we covered respiration yet? No, we haven't. Okay, so when we talk about anaerobic respiration in biology, right, they might not mention the enzyme there either, but they do like say that yes, it's catalyzed by enzymes, right? Because we're not using extracted enzymes in this case. If, for example, certain enzymes were extracted from a bacteria or a fungus or something else, and only those enzymes were used, and they'd mention, instead of mentioning yeast, they'd put in the name of the enzyme as a catalyst. Does that answer your question?
Yes.
Okay, so every time a batch is complete, the ethanol is extracted, and it's done by fractional distillation, and then a new batch of reagents is put in. Right, reagents are all the things that you put in for the reaction to take place, right? So in this case, the sugar sugar water solution and the yeast, those are the reagents. The yield of the process is only about 15%. Okay, the other way of obtaining ethanol is the hydration of ethene, and I believe we've done this when we were talking about alkenes. Remember? So ethene is an unsaturated hydrocarbon, right? Can you tell me what the formula of ethene is? Anyone?
Yeah.
The formula for ethene?
Ethene has two carbons
Yeah.
and five
No.
Two
hydrogen.
carbon and two hydrogen.
No and no. Neither 2 nor 5.
CN
CN,
H2
H,
H2N
yeah, CN H2N. So you've got,
more hydrogen.
and you've got 2 carbons. So how many hydrogens?
4.
4. And you've got H2O, right? But this is a gas, so you're reacting with steam, right? And it's a reversible reaction, actually. So we go this way. The conditions are 300 degrees centigrade. We've done this earlier, but still 600 kilopascals of pressure. Sorry, 6,000, not 600. And you are using phosphoric 5 acid catalyst. So phosphoric 5 acid catalyst. And you're ending up with ethanol. Okay. So just to write, this guy is steam. It's not liquid. And so obviously at 300 degrees centigrade, you're not going to have liquid water. So what's happening over here? You got ethene, and you've got water, and you write it out this way, HOH. It's a reversible reaction, and then you get your ethanol. Right, so obviously it's adding across the double bond, so one of the hydrogens goes to one carbon and the OH to the other, and now you've got ethanol. Any questions?
No.
So, right, there's a table in the book that compares the advantages and disadvantages of preparing ethanol by fermentation as compared to the hydration of ethene. So, fermentation is a low energy process, and the materials are readily available. The disadvantages are that it's a slow process, it has low yield, and right, it is not a continuous process. You have to take an entire batch, wait till the end, and then introduce a new batch. The hydration of ethene is faster, it is a continuous process, but the disadvantages are that it requires far more energy because, again, 300 degrees centigrade and 6,000 kilopascals. And it requires ethene, right? And we know that alkenes are obtained by the cracking of alkanes, right? So the materials are not as readily available. Now, with that, we're done talking about alcohols. I'm going to take a few minutes, right, or 5 to 7 minutes of your time and introduce you to carboxylic acids. So their general formula, right, there are other homologous series, and their general formula is CnH2n plus 1 COOH. So remember, right, this functional group is written separately, just like with alcohols over here, right? We wrote the OH. Like, you're not supposed to put the brackets, but like the functional group is written separately. And so, right, but in this case, the functional group was not like, it didn't have a carbon in it, and so all the carbons went here, right? In this case, uh, right, the thing to keep in mind is that the carbon in the functional group also counts towards the total number of carbons in the molecule, right? And so if I say, for example, that right, I have propanoic acid. So how many carbons does prop have?
5.
No, that's penta.
Sorry, 3. 3.
3.
Sorry, 3.
Now what I'm going to do over here to figure out how to make it propanoic, that's an A after the P, propanoic acid, right? So carbon count is 3. Now, how do I write out the formula? So keep in mind, right? COOH, write that down first. And so I already have one carbon. So how many carbons are left?
6.
Eh?
6. I'm
Carbon
sorry. 2.
2. And that is the N. So N equals to 2. Right? And so you put that over here. So what are you going to get? C2H
5.
5. Right? Because if I do C3H7 COOH saying, oh, it's propanoic, so there are 3 carbons, and I put that. How many carbons do I have in total now?
4.
Yeah, and so that's butanoic, right? So when we're writing down the molecular formula for this, just keep in mind that the functional group includes a carbon, and that counts towards the total number of carbons in the molecule. And so that's something to be, just attentive towards.
But like we have only 6 hydrogens.
Huh?
But we have like only 6 hydrogens
The
in
hydrogen,
like the
the hydrogen is not our main concern, right? Like I said, and as the book says as well, right, the main concern with hydrocarbons, organic molecules, are the carbons,
Okay.
right? So what defines the molecule is the number of carbons it has. The number of hydrogens can be more or less depending on what's going on with the molecule, right? So, right, in total you're saying, oh, you've got, right, so that would be CnH2n, right? But so or oops, wrong button. So you would say that, oh, I'm going to write it out as CnH2n because there are 3 carbons and 6 hydrogens, and I'm going to write it like this. Okay, so just so if you write it out like this, how does that make sense? Is the functional group 2 like oxygens, like what is it? And so okay, the number of hydrogens is not our primary concern. All right.
Yes.
Okay, so we do have methanoic acid, right? How many carbons are there in meth?
1.
And so I already have the COOH, so I have my 1 carbon over here. So what am I going to do?
Like we will have 0 carbons then
No.
on the others.
0 carbons on the other side. So this is what the COOH looks like, right? Does carbon have 4 bonds? Carbon makes 4 bonds. Is it making 4 bonds?
No.
No. So what am I going to do with the 4th bond?
Like we will add H on the
Yes,
other side.
exactly. Right? CnH2n. So in this case, n equals to 0. So 2n plus 1. So 2 times 0 plus 1 equals to how much?
1.
1. And that's what we're getting over here. So that is methanoic acid. Right? And then you've got ethanoic. So, right? What's the carbon count? Sobi, are you there?
Yes, sir.
Right? What's the carbon count on ethanoic?
2.
Right? I already have my COOH over here. So how many carbons do I have left? What's the N number?
1.
Yeah, exactly. right? So you plug that in over here, and so you got CH, how much?
1.
Eh,
No, wait. 2.
look at this.
3.
3. That's ethanoic. Right, we already have propanoic up here. We've done butanoic as well. Right, so these are the 4 acids you need to know. Drawing them out, right, we drew out methanoic, and so this is ethanoic, this is propanoic, and this is butanoic. What will their structural formulas be? What's the structural formula for ethanoic acid? This is the displayed formula, right?
Yeah.
What's the structural formula going to be?
2C.
2C.
Yeah.
Remember, we break it up into parts and we talk about
Oh,
each
sorry.
part.
Yeah.
So what's the structural formula going to be?
CH3
Yeah,
and C.
you write the functional group,
Okay.
right?
CH3.
So for methanoic and ethanoic, it's pretty simple. Propanoic,
3.
3 what?
3 carbons.
Yeah, but structural formula.
Oh, okay. CH3,
CH3,
CH2,
CH2, good.
OH.
COOH. Butanoic,
CH3.
CH3,
CH2.
CH2,
CH2.
good.
COOH.
Good. And I'll stop here. Okay, so the
Okay.
next time we will talk about a bit more about these guys, right? Uh, some of the reactions and what they do. There's not a lot to talk about, but we're out of time, unfortunately, right? Then we have esters to talk about. That's another homologous series, and then another kind of polymerization. The last time we talked about addition polymerization, and then we have to talk. There's another kind of polymerization, and we'll be done. So next week we'll definitely be done with this chapter, and so we'll be also almost done with the syllabus. Okay.
Okay.
Yeah.
Yes.
Okay.
Okay.
So yeah,
Allah Hafiz.
Allah.
Allah Hafiz.